Hello, this is Mr. Huff, and I want to do a follow-up video for the Simple Machines documentation for Principles of Engineering. Real quick, right off the bat, I saw issues with paying attention to details, omitting the project from the table of contents, even though it was the first thing we've done in this notebook. So make sure you're documenting things in the table of contents. Be sure to check the bottoms of the pages. Be sure those are signed and dated across the bottom of those pages. Fill out that section for every page. Another thing I saw is if you have a blank space that's more than 1/4 of the page, cross through it and sign your name on it and date it. Be sure you're doing these little things. When you generate concepts, I expect to see more than one concept noted. You should have your ideas and some sketches of your partner's ideas so that you can show that you thought through this problem more than just, hey, I'm going to do this one thing and I'm done, so let's go build it. You need to make sure you have multiple concepts. Also include annotations that explain the design and how it's going to work. Your final design sketches need to be much more accurate and tidy than your concept generation. I saw some final designs that the concept generation was actually much better. So be sure you're spending a little more time on these. They should be somewhat to scale. You should include some dimensions, approximate even. It doesn't have to be super exact. It's nice if it is, but it needs to have some sense of dimension and scale. And be sure to include annotations that explain important features and how it's going to work. I do want to say this. Do not sacrifice organization to make lots of information fit on the page. Spread your work out. If you're changing from one step of the design process to the next, label it and give it its own space. I saw many notebooks where we went across the top and then we worked on the left side and then jumped back up on the right side kind of halfway down and tried to squeeze everything in right there, or written sideways or something like that. So don't sacrifice organization to try to make the page hold the entire project. That's not what we're doing. You're breaking up these steps and clearly communicating those. And when you jumble it all together, it becomes really hard to figure out what you've done and what you're doing. So spread your work out. For data analysis, you need to get organized. You should label the calculations with what they're for. Are they for levers? Are they for wheels and axles? That sort of thing. Always include the formula, the substitution, and the answer with units at a minimum. This makes it really easy for me to see your thinking on paper. So you could pick up a notebook done like that in a year from now and understand what the calculations were. I saw a lot of, what shall we call it, number barf, just throwing a bunch of numbers down on the page and saying here's my final numbers. So that's not helpful. Get organized here. Also, I saw one student and he had his calculations and then he built a nice little data table at the end that summarized everything. That was super easy to digest. So you might consider doing that as well. During the evaluation, you should be approaching a paragraph length explanation of how did your machine perform, what was it lacking, what changes you made from the original solution. And also you should list and justify some improvements. You can't just say we should use different string, we should get rid of friction. You need to explain how you would do that and why that would help. So that's about all I have to say on this.